Assalamualaikum. Good day to our lecturer and to everyone watching. We are Group 4 consisting of Maulana Alif, NAJMEE KAYEM and KIVNANIA TANZU. Today we are excited to present our group project for STIDK 2114 Information Technology Project Management with our title The Smart Campus System. Our project focuses on delivering a modern integrated IoT-based infrastructure network paired with a unified cloud-native student portal designed to systematically optimize student services and facility management here on campus.
So, in this project, we focus on improving the smart campus environment. Currently, the university operates multiple separate systems across different departments. Their systems are not integrated, which means information is gathered and not updated in real time. As a result, this reduces operational efficiency and creates a less convenience experience for students and staff. Therefore, this project aims to address the gap by proposing a more integrated digital. So, there are several key problems identified in the current campus system. First, parking congestion is common and students often waste time searching for available spaces. Second, most facilities are still monitored manually, which is inefficient and not real-time. Third, digital services across campus are fragmented, meaning users need to access multiple systems separately. This problem affects students, IT staff, facilities management, and administration. However, this also creates an opportunity to implement an LOT-based smart campus system that enables real-time data, better integration, and improved efficiency. The Measurable Organization Value, or MOV, defines the expected success outcomes of this project. For this system, we aim to achieve several measurable targets. We expect to reduce parking search time by 30% within 3 months. We also aim to improve energy efficiency in classroom by 25% within 6 months. In addition, we target 100% integration of the student portal within 6 months. User satisfaction is expected to be above 80% based on survey feedback, and system response time should be less than 60 seconds. This outcome will be measured using LOT sensor data, energy reports, system audit logs, and user surveys. This project proposes a smart campus system using LOT sensors, cloud, and a central dashboard. The system helps improve campus operation by serving real-time parking, energy usage, and student services in one platform. The total cost is 45,000 ringgit Malaysia, covering hardware, software, and system setup. The benefits include reducing parking congestion by 30%, improving energy efficiency by 25%, and integrating all campus systems. We compare all the options, but they are either too expensive or not fully effective. So the smart campus system is the best choice, and we recommend it to proceed with implementation.
On this slide, we have our project charter. Our main objectives are to reduce parking search time by 30%, improve classroom energy efficiency by 25%, and fully consolidate all student portals within 6 months. We're working within a fixed 15 weeks timeline and a budget of RM 45,000. Our top risks are hardware delays and data privacy, which we have already planned mitigation for, such as ordering early and encrypting student data. We clearly define what we will and won't build. On the left, we have our in-scope item, IoT sensor for parking and classroom, a cloud database, a unified student dashboard, and API integration with existing system. On the right, we excluded off-campus transit third-party commercial apps like Google Maps, and we are not migrating legacy data, just integrating via APIs. We divided the project into 5 main work packages. As you can see, software development takes the largest portion at 40%, followed by hardware at 30%. This allocation reflects the hybrid approach we are using building both physical infrastructure and the digital platform simultaneously.
Moving into slide 10, we want to highlight our project schedule and baseline timeline. We map our 15-week timeline using a visual Gantt chart structure to manage task sequence and dependencies cleanly. This allows us to run our predictive hardware setups and iterative agile software sprints in parallel to maximize team productivity. To ensure strict execution control, we established 4 key project milestones. Milestone 1 in week 2, marking our project charter and MOV approval. Milestone 3 in week 9, confirming our core network infrastructure was ready. Milestone 4 in week 12, releasing our functional beta software. And finally, milestone 5 in week 15, representing our official system handover and PIR sign-off.
Our total project cost is Rm 45,000, which match the charter. The biggest chunk goes to hardware at Rm 20,000, followed by people at Rm 15,000. We also included a 10% contingency buffer of Rm 4,000 and 500 to handle any unexpected price fluctuations or shipping delays. This RACI matrix clearly defines who owns what. As you can see, I am as the planning lead. I responsible for scope, WBS, budget, and risk. The PM is accountable for the schedule and charter, while the BA takes responsibility for the business case and closing. This ensures everyone knows their role and there is no overlap or confusion. We identified 5 key risks. The biggest one are hardware delays and data privacy. Our response is straightforward: order hardware early and encrypt all student data to comply with PDPA. For medium risk like Wi-Fi overload and scope creep, we have mitigation plan like network stress test and a strict change control process. We want 99.5% system uptime, dashboard load times under 3 seconds, and data latency under 60 seconds. We also aim for over 80% user satisfaction from our UAT survey and 0 critical security vulnerabilities. We will manage closely with the administration and students because the high influence we will keep in the IT department satisfied with technical docs, and we will keep facilities management informed through training session. Each group gets the right level of attention to ensure smooth project execution. The team has a daily sync at 8:30 a.m. via WhatsApp and Trello. We report to the sponsor bi-weekly and we collect user feedback every sprint at weeks 6, 9, and 12. I personally handle communication with the IT department before handover and with our hardware vendors during procurement.
This slide showcases our actual project control tools and operational evidence. Rather than working in silos, we integrated our development environment. We utilize GitHub for precise software version control and code collaboration, tracking all code commits to prove balanced team contribution. Parallel to this, our Trello board visually map our workflow transitions in real time, from the project backlog into progress to code review and testing, and finally to done. Our active screenshot of these working systems are fully compiled in Appendix A16. We discuss our phased rollout strategy to minimize campus disruption. We begin with step 1, a localized pilot phase in 3 designated parking lots and 10 classrooms. Once our performance gates are cleared, step 2 is to scale the software updates campus-wide. Finally, step 3 covers the operational handover to UUM's campus IT department. To mitigate adoption risk and user resistance, we scheduled dedicated IT training workshop in week 14, paired with comprehensive administration manuals. Post-implementation review, or PIR framework. This is how we prove our system actually achieved the baseline measurable organizational value. We have scheduled quantitative audit cycles at 3 and 6 months post-launch. Specifically, we will audit IoT logs to verify our 30% parking search time reduction, utility bills to verify our 25% energy optimization, and connection audit logs to confirm 100% portal access consolidation. We reflect on our key lesson learned. Technically, we learned that complex physical hardware processes require a strict 2-week scheduling buffer, and gateway memory caching is essential to shield dashboards from occasional Wi-Fi dropouts. From a team perspective, running agile software sprints in parallel with predictive hardware setups successfully saved us 15 total delayed days of deployment. For future scaling, we recommend expanding our IoT nodes to campus shuttle routes and leveraging machine learning models to predict peak parking hours. Concludes for Group 4 presentation about smart campus system. Thank you very much and goodbye.